Now it's time to talk about the magic of confidence intervals. So we get an equation and we get to do a little bit of math with the confidence interval. So hopefully we understand what confidence interval really is now. It's this concept that I can report a number and I can assign a window to it. Well, here's my number. It could be, though, this low or it could be this high. I don't really know where the true value really lies, but I'm giving you a window. And when I give you that window, I am a certain degree of confident about the number. I'm 90% confident that it falls in that window. I'm 99% confident that it falls within that window. Okay, so how do I get the window? That's the issue. How do I get the window that I report with the confidence interval? And here is the equation that you will use to solve for confidence intervals every time. So here we go. That's the CI or the CL equation. That's what I'll abbreviate it as. Again, confidence interval for CI, confidence level for CL. And no matter which one I pick from, the 90, the 95, the 98, the 99, it doesn't matter. I use the same exact equation. And look at this equation. I don't want you to feel intimidated by it because it's a very short, sweet equation where you typically know all the numbers that you need to know to solve it, as long as you have that magic Blue's Clues table that we talked about in the previous video. All right, so let's break down all of these variables and talk about them for a minute. So let's start with the x bar. I'm going to come over here to the side. We've seen this x bar before, and the x bar really means what it always has, and that is the average. All right? So typically in a laboratory, you're going to do a result. One time is not good enough, though, so you're going to have to repeat them. And you do the repeats on them, and that repeat, you typically report an average. You do it more than once. So x bar here is the average that we've always talked about. Okay? So if you can do an average, you've got that piece of the puzzle already taken care of. All right, now let's talk about this S variable. The S variable is going to stand for what it's always stood for, and that's your standard deviation. Again, you're doing multiple measurements. You're averaging them together. And if you're doing multiple measurements, you can do a standard deviation. You can do it by hand if you're crazy, or you can let Excel do it for you with the simple little equals function button. So that's the standard deviation we've always talked about. There's no special thing that happens there either. So that leaves us two variables that are maybe new to us, and they're not that difficult to really pick out. So let's start with the first one up at the top, and this first one is the T. The T is what we call the student's T. You know, back in the day, when this table was first created by a mathematician, he didn't really want to put his name on it. The reason that he couldn't put his name on it is because he worked for a company. And this company put him in basically the statistics portion of the laboratory and told him there's got to be a better way to do the statistics reporting and reporting these numbers to their clients. So he went in and he did all of these mathematical concepts and formulas and equations, and he came up with all of these statistical numbers or constants throughout his experience and throughout his testing. So, because he worked for the company, he had a confidentiality agreement that he had to associate himself with. Because of that, he couldn't put his name on any of the experimental research that he did. So instead of his name, he used the word student. And that's what we still use today, student T. So this is a constant that we assign to these calculations. And that constant is found right here on the table, which is why you consistently and constantly need to look at the table and understand what it means. So if the question says you need a 95% confidence limit, what I would do is I would go to the 95% column, and these are constants that I would be using in that calculation. Remember, if it doesn't tell you confidence limit, you automatically go to the 95. If it says the 99% confidence level, I go to the 99% column, and these are the numbers that I begin to use in that column. Notice as you go down, the numbers get smaller and smaller and smaller. The larger ones are always up here at the very top. So that's the student t. That is the t variable. It is nothing that you calculate. It's something that you find from the table and plug into the equation. So now that leaves us with this bottom number, and this bottom number is n. And n is going to be the number of measurements. Okay, so the number of measurements, how many repeats did you do? How many testings did you do when you averaged them together? Did you test it 3 times and take the average? Did you test it 5 times and take the average? Did you test it 10 times and take the average? That is the number that goes there, the actual number of measurements that you took, right? If you did a triplicate, you did it 3 times, 3 would go into that equation. If you tested the item 10 times and did an average on the 10 measurements, 10 would go into that spot in the equation. So that is the n variable of the equation itself. So again, nothing that you have to calculate. It's something that you just look at and determine what the number is going to be. All right, so on this table, you've got to be careful, because over here in this column, it says degrees of freedom. So if I was going to assign a 95% confidence level, I have all of these numbers to choose from. How do I know which ones to choose? Which one out of that whole list do I pick to put into that equation? Well, the degrees of freedom will let you know which ones to pick. All right, so how do I calculate this degrees of freedom? How do I make all of this make sense and talk to each other? All right, so the degree of freedom is basically, again, it's not rocket science. Watch how hard this is. The number of measurements minus 1. Okay, so for instance, let's say I want 95% confidence interval of 6 measurements. That means I've taken an item in the laboratory, I've tested it 6 times, over and over and over and over and over. And I did an average, and I did a standard deviation of that, and I need to report a confidence limit. Well, for the variables of the equation, I need to know my student t, and I need to know the n. N is the number of measurements. How many measurements did I do? 6. So a 6 goes there under the square root sign. What about the student t? What number goes there? Well, I go to this table and I say, okay, well, here's my 95% column. Which number out of that column do I pick? Well, I did 6 measurements, but these are degrees of freedom. So I take my 6 measurements minus 1. That gives me 5. That is my degrees of freedom. So I'll go down to number 5, and then I go across. That's the one I would use for 50%. That's the number I would use for 90%. And that's the number that I would use for a 95%, 2.571. So that means my student t would be 2.571. My n would be a 6. My average, I would be able to calculate. I would just need to know what my measurements were. And my standard deviation, I would be able to calculate. I would just need to know what my measurements were. But that's the information that you need in order to use and interpret the table. So you need all of those pieces. So in the next video, we'll do an example, and we'll see how all of this works out. And we'll not just do an example of 95, but we'll do an example of a couple of other confidence intervals as well. But keep in mind that 95 is the most common, and that's the default if it's not spoken. Over here to the side, this paper kind of cut out on you when I scanned it. So 99.9, I will not ask you. All right? So just ignore that that column's even there. I will not ask a question that involves a 99.9 because as you can see down here below, it begins to cut the numbers off on you. These student T-tables can easily be found on the internet. You can go to Wikipedia. You can go to different textbooks. You can use math books. Student T-tables are going to be everywhere. The problem is that when you find a student T, sometimes they are given in degrees of freedom. Other times they are given in number of measurements. And you've just got to figure out which version of the table that you're using. So pay attention to that column. That is drastically important. Because if this was degrees of freedom with 6 measurements, 2.571 is what I would use. If I'm looking at the wrong table, I would look at 5 for another table and there would be a different number associated with it because it's not given in terms of degrees of freedom. It might be given in terms of just raw measurements. So this is the table that we'll use. This is the table that I'm telling you to print off and put in the front of your lab notebook and put in the front of your notebook that you're using to study for the class. And this is the one that we'll constantly refer to in the example problems. Ignore all the rest. They're out there. You can find them. You can use them. Just make sure you know what you're doing with it because that very first column can be different. So in the next video, we'll take a look at an example or two. We'll work through it, and hopefully you'll be ready to calculate your first confidence interval.